First set of operations that we're going to learn how to do with matrices is addition and subtraction, and this is a very straightforward process. Now, the first thing that you've got to know is that matrices must have the same dimension for you to add them and subtract them. And the reason for that is because we're going to identify each individual place of the matrix, and we're going to add or subtract that particular spot on each one of them. And so you can see here in example 1, what I've done for you is I've actually color coded the individual cells or the individual locations of each of the numbers according to their row and their column. And so you can see here in part A we have 3 rows and one column, excuse me. So we have 3 rows by 1 column, and we're adding it to 3 rows by 1 column, and so that checks off. Now, if we did not have a situation where the dimensions were exactly the same, we just basically couldn't perform this operation, and so there would be no answer for us. Now, you can see that the 3 and the 1 are both in the first row, first column, and so I've color-coded those with a blue so that you could see that addition of 3 plus 1 and 4. And then we've got the rest of the parts of the matrix, and you can kind of follow along according to the color coding. Now, in part B we have a little 2 by 2 matrix, and we're subtracting a 2 by 2 matrix, and of course you can see I have an 8 and a 2, and then I'm subtracting. So 8 minus 2 is simple enough. Now notice the red numbers, the 3 and the negative 7. We have to remember that if we're subtracting a negative number, we should put those negative numbers in parentheses, because that 3 minus a negative 7 becomes addition, and then that would be 10. And so you can see how that would work. So this is a very straightforward process. You just have to be very aware of the dimensions and the individual parts matching up to each other, and sometimes we call those corresponding parts. Very similar to what you learned in geometry in relation to polygons. So let's move on down to a sample problem. And so you can see here, sample problem number 1, you have 3 calculations to make. Let's go ahead and pause the video right now and try to work those 3. So hopefully you were able to do that. I'm just going to go ahead and work each one of these individually, and then I'm going to show you a little trick with your calculator on how to do these to kind of check yourself. So we can see here that first of all I have 3 rows, 1 column, 3 rows, 1 column. That lets me know that I can add the individual parts, and so then I'm going to do that. 0 plus 1 is 1. 4 plus a negative 9 is going to give us negative 5. And 3 plus 8 is going to give us 11. And I'm going to use these little square brackets. And that gives me a 3 by 1 matrix, just like the other matrices were. And so that's how that should come out. Okay, and now we have a 2 by 2, subtracting a 2 by 2, so that's going to be okay for me to do. So I'm going to do 3 minus 2, which is going to give me 1. I'm going to do 3 minus 0, which is going to give me 3, and it really doesn't matter what order I do these in, as long as the location is correct. So 9 minus a negative 3. That's the same thing as 9 plus 3. It's going to give me 12. Now I have negative 5 minus 5, which is going to give me negative 10. And I square that off with our matrices. You can see that's a 2 by 2 matrix, which is exactly what we should have expected. And then this last one, we can see we have a 2 by 2 matrix, but then we have a 2 by 1 matrix, and this right here should tell us very quickly, since our matrices are not the same dimensions, we cannot perform this operation. And you could write your answer in any number of different ways, as long as we get the idea of what you're trying to create there. Now let's just take a look at our calculator and see if we can look at ways to do this on our calculator. And you can see I've pulled up a blank scratch pad screen, so go ahead and pull your calculator out, and we'll walk through this. I'm going to go back to a sample problem part A, and I'm going to work that matrix. Now if you recall, right here next to the 9 symbol we had all these little templates in here for piecewise and absolute values, so I'm going to go ahead and click in there. And you can see on this middle row we have actually 4 different spots that we can do matrices. Now let's talk about each of these so you know which one to press. This first one, you can see that it's a 2 by 2 matrix. It is specifically a 2 by 2 matrix. You'll get exactly a 2 by 2 matrix. Okay. Same thing with this second one. This is a 1 by 2, one row by 2 columns. You'll get specifically a 1 by 2. And then this one is a 2 by 1, and you'll specifically get a 2 by 1. So those first 3, what you see is exactly what you get. Now, this fourth one, however, it shows a 3 by 3, but it's not specifically a 3 by 3. What this is an open template that allows you to create your own dimensions. Okay, and so if one of the first 3 doesn't fit the problem that you're doing, you're going to have to pick this fourth one. And so that's the one I'm going to pick for this problem. Now you can see here that it simply asks for the number of rows and the number of columns. And so in my part A, I have 3 rows, so that one's good. And then I can tab down to the number of columns. Now in the number of columns, I'm going to backspace. I'm going to replace that 3 with a 1. And I'm going to hit OK. And you can see here that I get a template for 3 by 1 matrix. Now if you got your dimensions mixed up and you accidentally put 1 by 3, it would give you the matrix template would not look like what's on your paper, and you would know that you've got those dimensions backwards, and so you just need to go back in and fix that. Now all I need to do is type in the numbers here. So I'm going to 0, and then if I want to get to the next template box, I can either use the arrows or I can use the tab button. So now I've got 4, and then I've got 3, and I'm going to tab out of this and make sure I get that red cursor, so to speak, outside the matrix, and then I'm going to hit plus. Now I need the second matrix, so I'm going to go in there, same process, I'm going to get a 1, and then now I'm going to hit 1 and -9, so I'm going to use that little button for negative. I'm not going to use the subtraction button. And then I'm going to have 8, tab out of there, and then now I'm just going to hit enter, and it's going to give me my resulting matrix. Alright, so that's a good look at how to use your calculator. So now you can check yourself with the calculator function. Let's look at one more type of operation here. This next operation is called scalar multiplication, and the reason we call it scalar multiplication is because the scalar is really kind of like just a multiple. We're not multiplying 2 separate matrices at this point. We're really just multiplying one singular number times an entire matrix. Now this has a similar effect of the distributive property. So if you look here at example number 2, we have a 3 that's being multiplied times this entire matrix. So what that means is I need to multiply the 3 times everything in the matrix, and so it kind of distributes to every part of the matrix, and you can see our second step here, we've done that, and then we get a resulting matrix. Okay, so that's pretty straightforward enough. So why don't you go ahead and try to work sample problem 2. We start with a scalar multiplication, and then in part B we put all of it together. Alright, so go ahead and try that now. Okay, so we come back here and we see that we have 6 times everything inside there, and so I'm just going to multiply 6 times 2, which gives me 12, 6 times 8, which is 48, 6 times -3, which is -18, 6 times 4, which is 24, and our matrix should be the same dimensions as the previous matrix. Alright, now this last one, you kind of have to deal with order of operations similar to the way you would with real numbers, and so I have to do the scalar multiplication before I can do the addition. So I'm going to go ahead and multiply -2 times everything inside the first matrix, and notice I'm only multiplying -2 times the first matrix. There's no parentheses or anything that would imply that I'm doing it to both matrices. So I've done the scalar multiplication. I'm just going to rewrite, and then I can do the addition of those two, and so that's going to give me -6, 6, and 6, and 9, -14, and -4. Now, if you did all this in your calculator, that's absolutely fine. Just make sure you understand the principles behind why it works and how it works, just in case you get in a situation where you're not being allowed to use your calculator.